Back to Further Solutions Academy. Further Solutions Academy. Encourage us more, help us to share our video, and also if you have not subscribed before, make sure you subscribe before you leave here. Just press on your subscribe button, and presently we have over 250 videos on our platform. It means you can come to this platform and learn any topic of your choice, talking about physics, further mathematics, and chemistry. And also, if you want to leave comments, you can leave comments, and you can drop email. We will surely attend to that. And also, you can use this number to reach us. 80344959990. With this number, you can call us, and also you can WhatsApp us, and also Telegram is allowed. Telegram is allowed. Either of the three. Further Solutions Academy. What I have for you on this video, well, on temperature, and I've done two videos earlier, which is introduction part and the calculation part of thermometer. Now this time around, I'll be working on resistant thermometers, that's what I have for you on this video. By the end of this video, you will understand everything on this part, how to calculate it, how do we relate it, and so on and so forth. Now, presently, when we talk about resistant thermometer, we have to understand that we are using temperature. We are relating temperature with a resistance, which is a thermometer with a resistance. And I've told you earlier that it rise. This thermometer rise and fall is a mercury on a glass test tube, which rise and fall. Which we have done that. If you need anything on that, you can check on our previous video. And let me quickly go to what I have for you now. Now, if I'm talking about resistant thermometer, there is proportionally resistant relation between the resistance of metallic conductor, e.g. and its temperature. Okay, that is what I can say on this. It means we are relating it to what? Metallic conductor, which is, we all know what metallic conductor is. And also because there is a corresponding relationship between resistance and temperature. We can apply same procedure used in liquid, in glass thermometer. Now, I've told you liquid in glass thermometer, which I've told you that there will be corresponding, which is I was using and the temperature, which I told you that we have three of them, which is we have Farad, we have Celsius and Kelvin, which wherever you're working on, you are to use it. Now, this time around, it's just the same thing of that, the one we have done earlier, which is in addition, what we're trying to do here is that I can have this particular theta equals to R naught minus R100 minus R naught multiplied by 100 degrees Celsius. Now, this is the formula that you can use if you don't want to use the procedure earlier, which is very, very simple to use. We have, this is what you are looking for, the resistance that is not given. Why this is the resistance of the beginning, which is this is the final resistance, which is the also, you know, final minus initial, which I've told you that is how to find distance of the now let me quickly define it. If I have R100, it means upper fixed point, and if I have my R naught, it means my lower fixed point. Now that is what I'm trying to explain there. Now with this, let me show one or two examples and you'll get it right. Now, talking about example now. Now, having this type of example, the first one is that I have a question here. A resistant thermometer has a resistance of 10 ohms at 0 degrees Celsius and 70 ohms at 100 degrees Celsius. If it records 55 ohms in a certain medium, calculate the temperature of the medium. Now, I'm to calculate the median of that, what I'm given. Now, I've told you earlier that when you have something like this, we are doing the same on our previous video. But this time around, we are not using, millimeter or wherever. Now we are now strictly on ohms, which is resistor. We are strictly on ohms. It means we'll be working along on what? Ohms. But the same procedure. The same procedure. And how do I go about this? It means solution to this problem. The same way on the previous video, which is I will do the corresponding, which is this time around we are relating Celsius with ohms. It means the resistant thermometer can be corresponded with the Celsius scale. Now, which is what am I trying to do? This is just like I'm having something like this, I'm having something like this. Now it means I will be having, this will be upper fixed point and this one will be lower fixed point. We are talking about 0 degrees Celsius, and we are talking about 100 degrees Celsius. Now, at 0 degrees Celsius, this read 10 ohms. At 100 degrees Celsius, it reads 70 ohms. Now, at a point, it reads 55 ohms, which is, let's call this one 55 ohms. Now, what we are looking for here, we do not need. Let me call it theta. Now, I use theta to denote unknown region here. It means it's here that I'm working towards, which is what I'm looking for, is there. And I told you that my final minus initial. What is my final? It means here minus here. It means I'll be having 55 minus 10 degree divided by 70 minus 10 degree. Then 10 ohms equals to theta minus 0 degrees Celsius divided by 100 degrees Celsius minus 0 degrees Celsius. That is, we are talking about ohms, 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 ohms. Now, with this, I think my problem is half solved. What am I working towards? I'm working towards Celsius, which is theta is my target. It means I'll be having this, and this will give me 45. I'll be having 45 divided by this one will give me 60, which is equals to theta divided by this one will give me 100 degrees Celsius. Now, since I have it this way, I can now continue, any way you want to do it. We are good to go. If I want to do it, okay, we are not doing mathematics. I can say that 60 theta equals to 45 minus 100, times 100, which I divide both sides by what? 60 by 60, which I have theta equals to, this will cancel this, and I'll be having, it will be 75 degrees Celsius. Now, I must put my unit on it. It's very, very important, because this one will tell us that what we are working on Celsius. That is why we have, and I've told you that we have Farad, we have Kelvin, and we have Celsius. And if you want to read more about this, you want to know more about this, you can go and read your state of matter very well. They are very important. Now, that is example 1 on this part. Now, another one. Now, okay, let me show another example. Now, the lower fixed point and upper fixed point of a resistant thermometer are 0.5 ohms and 35 ohms respectively. If it records 2.5 ohms in a certain environment, what is the temperature of the medium? In Kelvin. Now, this time around, I'm working towards Kelvin. Now, And what did I know about Kelvin? I've given you the scale on Kelvin on our previous video. I gave the one of Farad, the one of Celsius, and the one of Kelvin. And I said that Kelvin is always from 273 to 373, which we all know that. And the Celsius, I said Celsius is from 0 to 100 degrees Celsius, while Farad is 32 to 212. Please take note of those things. They are very, very important as far as temperature is concerned. Now, when I have something like this, I want to solve this problem. The first thing I need to do, this question, you are having only ohms. Nothing is given to you on what? On Kelvin, but you are looking for something on Kelvin. Now, and you are relating with the Kelvin scale. Now, what you need to do is that you have to know the final and initial point of Kelvin. It means I must first on ohms and also on Kelvin. It means my Kelvin read from 373 Kelvin to 273 Kelvin, which we all know that. Now, the first one, upper and lower fixed point. Upper and lower, it means these are the value respectively. These are the value respectively. It means my lower will be what? 0.5 ohms, and the upper will be 3.5 ohms. Now, since I have it this way, and if it records 2.5 ohms in a certain environment, now 2.5 will be somewhere here, which I did not know it on the Kelvin scale. It means I'll be having it 2.5, which I did not know this on Kelvin. Let me use my theta Kelvin. Now, it means I don't know it. My theta means something is missing. You know, I can put X, I'm satisfied with this. That is why I'm putting now the same thing you do, which is you take I've done the proportion, and I've told you that my final, this minus this, which is 2.5 minus 0.5 divided by 3.5 minus 0.5 equals to theta minus 273 divided by 373 minus 273. Now, since I have it this way, I think I can do what I have to do on the other part, which I will continue by having it in this form. I have this shall be 2, while this shall be 3, equals to theta minus 273 divided by 100. Now, I will successfully cross multiply. We know this is a simple mathematics that we can cross multiply. Now, it means I'll be having 200 equals to 3 bracket of theta minus 273, which I have it 3 theta minus 273 times 3, which I'll be having 819 equals to 200. 819 equals to 200. Now my 3 theta will be equals to 200 plus 819. As far we are not dealing with, oh sorry, I'm not talking about mathematics anyway. Let me go far away from the brain. Now I'll be having 1019 equals to 300, which is 3. I divide both sides by 3, which my theta will be equals to 339.67 Kelvin. That's what I'm looking for. That is all. That is all I'm looking for. Now, not to complicate matter, I will be stopping this class here. Before I stop, I started the video with resistant thermometer, which I'll let you know what is resistant thermometer, which I've told you that before you watch this video, make sure you watch our 2 previous videos. They are very, very important. And also, I've told you that this time around we are strictly on resistance, resistor, which is we'll be using ohms. We are working along with ohms. While liquid in glass thermometer, I've told you that can be in mm, can be in cm, can be in whatever scale you are working towards. But this time around, you are strictly on ohms. It means you'll be taking your proportion with what? Ohms, with a what? With the scale. And I've told you that there are 3 scales: Kelvin, Celsius, and Farad, which I've told you earlier. And example with 2 examples. Make sure you follow it, and if there is any problem, just drop a comment. Once again, Further Solutions Academy. Help us to share, and also if you have not subscribed, you can subscribe on it, and also you can meet us on this number. Please, so I know you are enjoying this video. Telegram is allowed. Now I know you are enjoying this video. Please subscribe and share. Thanks for watching.